Welcome to this eLearn Security video lesson on Linux Exploitation Information Gathering. In this video, we are going to cover several things we should be on the lookout for when conducting information gathering tasks against a target organization, in addition to showing how we can automate some information gathering tasks using the Bash shell and other tools. With all information gathering tasks, as it relates to gathering information from networked systems, we usually will first conduct our port scans, identify any listening ports, and then move on to enumerating those services to see if we can identify methods we can use to determine service versions for potential exploitability, as well as enumerating for the existence of users for those systems, which we can then use to conduct our attacks, such as dictionary brute force attacks, for instance. One of the services we'd like to cover is known as the name or finger protocol and allows us to conduct enumeration of users of a Unix system when the service is exposed, which can be found listening on port TCP79. Although the protocol dates back to the early days of Unix, it is quite often, to this day, found during internal penetration testing engagements, specifically within financial institutions, critical infrastructure organizations, and other environments which rely heavily on the use of Unix-based or Linux-based platforms to conduct their routine tasks. And, for this reason, it shouldn't be overlooked as a potential source of great information we can use during our engagements. As we do for most of our port scanning tasks, using Nmap, we can first identify that port 79 is listening on the target system. Furthermore, once we've identified the port is open, we can use the finger nmap nse script to initially query the port for information. As we can see, the NSE script was able to confirm the existence of the root user on our target system by querying the finger service. We can also determine such things as login time, idle time, office phone number if available, email addresses, and even the user's current shell, in addition to other information that might be related to the accounts. Now that we know our target is revealing information about users via the finger protocol, we can further enumerate the target for more users. For this, we can use the finger client. We simply run the finger program with a username as the second argument, followed by the @ symbol and the target IP address. As you can see, we can also query a system for potential service accounts as well. We can see from the output that we've confirmed that the SSHD service account is configured on the system, and we can also see that the service account is configured without a login shell, as can be seen with the /user/sbin/no login specified for the shell. Querying the system for these service accounts can also be useful to us in our quest to determine other services the machine may have running or configured. Our first goal is to enumerate the system for common Unix accounts. Furthermore, we can automate this process by using bash for loop in addition to using Metasploit's Unix_users.txt list, which can be found on Kali Linux. Our bash for loop can be something like the following. With this bash for loop, we're essentially constructing a loop that will iterate through the list of names in the Unix_users.txt file while redirecting the results to a file we can call valid_users.txt. We can see from the results in our valid_users.txt file, we've been able to validate several accounts, including any relevant information, such as if the account has a shell configured for it, in which case, for later tasks, we would conduct dictionary attacks against those users in an attempt to gain access to the target hosts. Of course, We can take this one step further by utilizing the statistically likely usernames list we covered on the Information Gathering course module. We can also enumerate the finger service for even more users. For this next segment on Linux exploitation information gathering, we'll demonstrate a tool we can use to conduct local enumeration once access has been obtained to a system as a low-privileged user. Although it's just one element in several that we should use to conduct local information gathering of a system, using automated tools can often reveal some misconfigurations we might miss through manual enumeration, and can also buy us a little time in regards to engagements where time is of the essence. The tool we're going to demonstrate is known as Linux Priv Checker and can be downloaded from the GitHub link shown below. Linux Priv Checker will search the system for common misconfigurations, permissions issues, SUID root executables, world writable files, and several other configuration issues which can lead to privilege escalation on a Linux system. We're going to assume we already have some sort of console access to the system, either through a reverse shell, bind shell, or some other exploit, and can execute commands as our low-privileged user, in this case, users we can see from the ID command output. Another point to note is that the Linux Priv Checker script is written in Python, so we must also be sure that Python is installed on the target. We can confirm that Python is installed by running the python -- version command. Python is installed on the system. Great. Once we've confirmed we have Python on our target, we'll need to transfer the script to the system. For demonstration purposes, we'll download the script from its GitHub page into the target's /temp directory. Now that we've downloaded the script, we can execute the script with a Python command along with the script name, and we'll also direct the output to a file called enum, which we will view once the script is done running. Now in viewing our results, we can see that the script has done a good deal of enumeration for us. And we also can see that it identified an interesting entry in the /etc/sudoers file for our current user. As we've previously learned about sudoers entries and the sudo command, which can lead to privilege escalation, let's see if we can use the /user/bin /apt-edit-sources space // to our advantage and obtain root level access to the target. Now we can see that when we try to sudo above apt-edit-sources command with a long path to a file of our choosing, in this case, a non-existent file called foo in the /temp directory, we're first prompted to choose an editor we'd like to use. We want to select option 3, vim.basic, because we already know that vim will allow us to execute a shell escape to root. Let's select the 3 option, and then execute the shell escape command for vi, which is :sh. Since we are able to execute /user/bin /apt-edit-sources as root to a file of our choosing using a long path name, and then choosing vi as our editor, our shell escape command was also run as root, and has given us a root shell. We are now the root user. It is at this point that we would like to start conducting our post-exploitation tasks as our newly acquired root user. And this concludes our video lesson on Linux exploitation information gathering. Thank you for joining us.